Hi, my name is Charlie. I'm one of the authors of S6, Semi-Supervised, Self-Supervised, Semantic Segmentation. I don't know about you, but I sure am excited about the alliteration in this title. But I'm even more excited about the progress we've made in dealing with problems where it's too expensive or too difficult to collect enough data to train deep models. So sit back, relax, and enjoy.
In recent years, deep learning has witnessed great successes in wide-ranging applications. However, these techniques require vast amounts of annotated data. In some applications, domain experts are required to make annotations. This process can be slow and very expensive. Even more troubling are applications where even collecting the data is also slow and expensive. This is the case for oil and gas exploration. First, in the acquisition step, large-scale seismic surveys are performed inland or offshore by geophysical E&P companies to evaluate the prospect of new hydrocarbon reservoirs in various geographical locations. These surveys generate vast amounts of raw data. This raw data undergoes a series of processing steps to convert the raw seismic data into a migrated seismic volume that accurately reflects the underlying geology and structures of the subsurface in the survey area. Then, during the interpretation process, this 3D volume is analyzed and studied by interpreters and geophysicists to generate a 3D geological model of the survey region. Finally, if the geological model indicates the potential for economically viable hydrocarbon reservoirs, production wells are drilled and work on field development and production starts. In this work, we will take advantage of the F3 block. When compared with its natural image counterparts, it becomes clear the challenge that we face. For the F3 block, we have access to seismic attributes as well as facies annotations. Facies annotations are a stratigraphic interpretation and is a major component of seismic interpretation. It provides a view of the sedimentary layers and the depositional environments. For our experimental setup, we are going to be comparing unconstrained versus constrained semantic segmentation. Given an input image, which is a seismic attribute, the model will then predict the facies annotation. The difference here between this unconstrained and constrained model is that for the constrained model, we will also have the model try to reconstruct the input, which is the seismic attribute. And our hypothesis is that by constraining the model to reconstruct the seismic attributes, we'll be able to maintain more information that's relevant for facies classification. Now for the results. The unconstrained model, when using different proportions of training and test split, we can see that even with a larger proportion of the training set, the intersection over union is actually decreasing as we increase the size of the training set. Whereas when we're constraining with the reconstruction, the intersection over union actually increases as we would expect it would. So we can clearly see that the constraint for reconstruction is actually significantly contributing to improved performance. We can also see this pattern reflected in the qualitative results. Notice the unconstrained at 6% has lost all detections of the scruff group, while constrained 6% retains that all the way through 4% and partially in 2%. Thank you so much for your attention. If you're interested in more work like this, please visit our group website linked below. There you can find related works, code, and contact information if you want to chat about any of it. Again, thank you.